Okay, so on to question 8. Question 8 just asks, what are the different functional groups in the molecule? So it doesn't look like they show a molecule, but I guess what the junior tutor said was they just showed almost all the different functional groups you can have ever in a molecule. So this is a very large, probably fictional molecule that they have here, showing all the different types of functional groups that you could have. So when we have an oxygen in between two carbon groups, this is known as a carboxyl group, or as an ether. An amide group is when we have carbon double bonded to an oxygen and has an amine group as well. OH is an alcohol group, so this is also known as hydroxyl group. When we have sulfur covalently bonded with oxygen, this is a thiol. When we have a double bonded oxygen on a carbon, this is a carbonyl group or a ketone. Carbon just bonded with NH2 is an amine group. When it's bonded with either chlorine, fluorine, or bromine, this is a halo group or like a halide. And they have amine group again. So functional groups are specific groupings of atoms within molecules that have their own characteristic properties, regardless of the other atoms present in a molecule. These functional groups will undergo the same type of reactions regardless of the compound of which they are part of. However, the presence of certain functional groups within close proximity can limit reactivity. Some of the most common functional groups and their properties are, so they show hydroxyl, that is polar, and it is made up of 1 hydrogen and 1 oxygen. Amide, so presence NH2, carbonyl. So this is also known as a ketone. Carboxyl. The carboxyl group is made up of a carbon double bonded to OH. They have the amine, thiol. I think they meant to make, this should be an oxygen. Like if you look at an actual carboxyl group, it has a double bonded oxygen on the carbon and an alcohol group. This is also known as a carboxylic acid. So the same thing down here when they say carboalkoxy, it's actually not a double bonded carbon. It is a carbon that is double bonded to an oxygen and single bonded to another oxygen in the middle of a chain. So this is carboxyl alkoxy. So I'll just take note. Maybe it was just a typo. For the halo, chlorine can be any halogen. And then finally, an aldehyde is double bonded oxygen and a single bonded hydrogen to a carbon. Okay, so this solution in depth and informative. However, for the carboxyl and carboxy, this even how? Yeah, I guess it's just not that common of a word. Carboxyl group.